Why are we here in the spooky cellar of the Atrecht College? Well, we're here to see some dead animals that have been dead for millions of years because this cellar actually houses a fossil collection, well, some fossil and some recent specimens of gastropods and bivalves, which is just the scientific name for snails and shells. There's the odd plant and horseshoe crab fossil in between, but it's mostly that. Since the 70s, not much has really happened with this collection. Back in the 70s, it was organized and most of the specimens were packaged in plastic bags, but since then it's been pretty much untouched. Recently, there's been efforts to reorganize everything and get an overview of what is actually present in the collection. And I've been here working on my honors program where I've been cataloging a subsection of the collection and looking at how the names, the taxonomic names, have been changing since they were collected, because since the 19th century, obviously a lot has changed in our understanding of taxonomy and phylogenetics.
I'm going to do a little show and tell, basically, of my favorite specimens from the collection. But first, I want to illustrate that this is pretty normal looking bivalve. Bivalve because they are made up of two valves, and inside here is where the organism lives that is producing this shell. Now, bivalves have a massive diverse array of morphologies, and they've been adapting for millions of years to many different types of habitats in the ocean and in fresh water as well. And I have here some pretty cool looking specimens from the oyster family. So this is Ostrea electra and Ostrea sifax. And I think they're really beautiful, just aesthetically. And the weirdest one that I've got here is Ostrea carinata, which I thought looked kind of like a worm. It looks segmented, but these zigzags are just the patterning of the shell, and you can see that it would have opened sort of like this. The hinge is here, so it would have opened like that, really. And the mode of life of oysters hasn't changed that much. They cemented themselves to a hard substrate and would have opened just enough to filter out some food particles from the water column. They use their gills to catch food particles from the water, which is kind of like using your lungs to catch food. Kind of, because evolutionarily lungs and gills have different origins, but they have a similar function, but, well, kind of, yeah. So these oysters still look rather oystery, but we have another group to present here that are one of my favorites because they're pretty weird for bivalves. It's evolution just took a bivalve and went a little crazy with it. So we have one valve here that has become elongated, and this would have been attached to the sea floor. And on top, you have the cap of the rudist that would have been able to open a little to also filter feed. But the caps of rudis could be round or swirly or star shapes, like they were real fashionistas of the Cretaceous era. Rudis appeared around the early Jurassic, I think. Let me just check that I'm not late Jurassic. They appeared in the late Jurassic, and they became quite diverse during the Cretaceous. The Cretaceous was actually a pretty harsh period in the history of the ocean. It was a lot hotter and a lot saltier than it is today. It was around 6 to 14 degrees Celsius warmer, and corals can't deal with that. Corals nowadays are already suffering a lot from climate change. So in the hot ocean of the Cretaceous, the corals just couldn't compete with rudists, and that's why these rudist reefs could build up in massive proportions. They could be hundreds of meters big, tall, and just run on and on for hundreds and hundreds of kilometers across continental shelves. And the golden age of the rudis was during the Cretaceous. They mysteriously disappeared towards the end, but not quite at the mass extinction at the end of the Cretaceous, the extinction that killed the dinosaurs. They disappeared at the end, and there's some theories about why they disappeared, possibly due to the cooling of the ocean and a drop in sea level, but that is still being studied. The next specimen I have to show is also a bit of a fashionista. If there's anything we can learn from this collection, it's that humans love collecting shells. But there is actually a snail that enjoys collecting shells as well. This is a Xenophora. I'm not sure about the species, but all of the species from this genus, they will collect shells, pebbles, any kind of debris that they can find on the ocean floor and cement it to their own shell. Why they do this? Well, it could be partially for camouflage, but it's also thought that the shells, they stick out like the spokes of a wheel, and this helps them anchor themselves into soft sediment, which stops them from being washed away by currents and stops them from sinking into the sediment. And the word xenophora, it literally means in Greek bearing foreigners, because they're carrying little foreign objects. Yeah. This next one that I've got here is a very delicate shell. And this one is not made by a bivalve or a gastropod. It's actually made by a type of octopus. And it doesn't have a very fitting name because it's called a paper nautilus. The paper part is fine, but it's not actually a nautilus. It's more closely related to the octopuses. And paper nautiluses will spend their whole lives floating in warm waters of tropical areas. And in the past, it was thought that this shell was used as a little boat to carry the nautilus. And they have two very strange arms that look like little wings. And that's what started the myth that they would use these little wings to catch the wind like a sail and then sail around in this boat, which is really, really cute. But that's not at all true. It's just a sailor's myth. The shells are actually a type of egg chamber. Only females have them. The females are much bigger than the males. And those strange wing-like tentacles that they have are actually modified tentacles that secrete this shell. And it's an egg chamber to keep the eggs of the female safe while she's taking care of her babies. So the last of the bivalves that I have is another very weird one. This is Malleus malleus, also known as a black hammer oyster, which makes sense because it kind of looks like a hammer. When I first found this in the collection, I showed it to my professor and he had no idea what it was. And he looked at it and went, well, I guess it's a bivalve. And what you can see is these are the two valves. They're just very modified, and it can probably open just a little like this to filter feed. Now, it turns out that they're actually quite common in the Indo-Pacific Ocean. They can be found off the coast of East Africa all the way to Melanesia and between Japan and all the way south to Queensland. Now, this particular individual was stored with a card saying Malleus malleus, but it's not black like a black hammer oyster, so it might just be an exception. It might be a different species. I don't know. I just know it looks pretty cool. So the last specimen that we have to show today, which some might consider cooler than the rest because it's just a big shark. It's Megalodon. It's a Megalodon tooth. Ta-da! Ah, it's so big. I don't think this is even a particularly big one, but people tend to think it's pretty cool. Megalodon was a really cool shark. They were the biggest shark and the biggest fish ever, which is, if you're the biggest of anything ever, that is pretty cool, I guess. They swam around from the early Miocene epoch all the way to the end of the Pliocene. Now, these sharks, we can estimate the size that they had when they were alive using correlations between tooth size and body size of modern sharks like the great white shark. So estimates of adult male megalodon sharks range for between about 10 and 17 meters in length. And female sharks were even bigger than that. So Megalodon has a bit of it's had a reassignment in its taxonomy. This specimen was stored together with a card saying Carcharias Megalodon. I don't know if I'm pronouncing that right, but whatever. Now, originally, Megalodon was assigned to Carcharodon, which is the same genus as the great white sharks. They thought they were closely related basically because the tooth of Megalodon looked similar to that of the great white shark. although there are some key differences. But nowadays, most paleontologists have moved the megalodon species into a completely different genus, and they believe the two families to have split at the start of the Cretaceous. Why it's written here as Cacharias and not Cacharodon, I have no idea. So what is the future of the Atrecht College collection? Well, currently the potential for the collection to be digitalized is being explored in the context of the DISCO project, which is a horrible acronym for the digitalized, come on, I can do it. Distributed system of collections. Are you filming it?
Yeah.
Oh! Of scientific collections. It's a distributed, I knew one word was missing. It's a distributed system of scientific collections. And this is actually the biggest collaboration between natural history museums, universities, zoos, botanical gardens, and other collection holding institutions across all of Europe. And they're working together to create an integrated research infrastructure that basically what it means is that all these collections will become more accessible to researchers internationally. So hopefully something interesting might be learned from the specimens that we have here.